Hello everyone. In this video, that is the third video of atomic structure and chemical bonding, we are going to study the arrangement of electron in an atom. As we know that the center contain positively charged proton and neutron have no charge. Almost all the mass of an atom is present at the nucleus. So nucleus is very small and highly dense. Around the nucleus, electrons are revolving in certain energy level that is called shell. There are shells. You can see four type of shell: K, L, M, N. It may be O, P, Q, R. 1, 2, 3, 4, 5, 6, 7. We can say even. These are the energy level. First energy level K, second energy level, third energy level, fourth, it may be fifth, it may be sixth, it may be seven. So now seventh shells are possible as per the elements known according to the modern periodic table. Now K shell is the first shell and have maximum capacity of 2 electron. So only 2 electron can stay in first shell, first energy level. According to the rule, that is 2n square, where n is the number of shell. If n is 1, means first shell we are talking about, put the value of n 1, that is 1 square, it will be 2 into 1 square, it will be 2. 2 electron can be filled in K shell. In L shell, that is a second shell. If you write the value of n is 2, so 2 whole square, it will be 4 to the 8. So 8 electron we can put in L shell, that is a maximum capacity of second shell. In third shell, maximum capacity is 18 according to the same formula. In N shell, that is a fourth shell carrying maximum capacity 32 according to the same concept of maximum electron capacity. Now, if you want to write, we want to discuss the electronic configuration of different elements in class 11th class 9th standard. We are having the elements up to atomic number 20. Every student must learn the element's name with their atomic number till 20. Now hydrogen have 1 electron, atomic number 1 electron in outermost shell, so K shell will have 1. Helium have 2, it will have 2 in first shell. The maximum capacity of first shell is 2. If there is only 2 electron in first shell, there is no electron in L shell, second shell or third shell, we can say duplet is complete. Lithium 3, 2,1, beryllium 4, 2,2, boron 2,3, 2,4, 2,5, 2,6, 2,7, 2,8. In case of neon 2,8, there is no electron in third shell and the outermost shell is the second shell that contain 8 electrons. We can say octate is complete. In case of sodium, we cannot put more than 8 electron. So in atomic number 11, it will be 8 electron in the second shell and the remaining electron will be in third shell. In case of potassium 19, there will be 2,8,8,1. Now here in the third shell, the maximum capacity is 18. But we cannot put more than 8 electron till the fourth shell carrying 8 electron. If the fourth shell carrying 8 electron, so the next electron will be filled into the fourth shell till it become 18. So, but we are having syllabus up to 20, so we will write 2,8,8,1. In case of 20, it will be 2,8,8,2. Take the screenshot of this screen and write down in your copy. In this screen, we are going to discuss isotopes of carbon and chlorine. As we have already discussed in first video, isotopes having same atomic number but different atomic masses. In case of isotopes of carbon, there are 3 isotopes of carbon having atomic number same, that is 6, atomic number different 12, 13 and 14. Why atomic number is different? You can see here, you can take the neutron. Neutron is the difference between mass number and atomic number. So 12 minus 6, it will be 6. In case of carbon 13, 13 minus 6, it will be 7. 14 minus 6 is equal to 8. So due to the different number of neutrons, their mass number is different and they form isotopes. In case of chlorine also, there are 2 types of isotopes of chlorine that have atomic number 30, atomic mass, your mass number or mass number we can say 35 and 37. So chlorine 35 and chlorine 37. If you will see, atomic number is same 17. Now proton is same 17, electron is same 17. But in case of neutron, you will see that there is a difference between a mass number and atomic number, it will be 18. Mass number minus atomic number 20. So chlorine 35 have 18 neutron and chlorine 37 have 20 neutron. So due to the different number of neutrons, they are forming isotopes, and isotopes have some different properties, but their chemical properties will not change because they have same number of electrons. If you are talking about duplet rule, duplet already we have discussed. Duplet means first shell carrying 2 electrons, there is no second shell, first shell is the last shell. If first shell is the last shell and carrying 2 electrons, it is called duplet and gain stability. In case of helium, helium is the most stable noble gas. Lithium ion, lithium atomic number is what? 3. After loss of 1 electron, it becomes 2. Beryllium, atomic number 4. After loss of 2 electron, it becomes 2. Hydrogen, atomic number 1. After gain of 1 electron, it becomes 2. So in all 4 cases, the duplets are complete. What is octate rule? Octate rule, the elements want to attain 8 electron in outermost shell except helium and first shell. Second shell, third shell, the second shell onward we can say if element having 8 electron in outermost shell, they are going to complete their octate because they are attaining the electronic configuration of nearest noble gas. See here neon having an atomic number 10 with electronic configuration 2,8. It is the second most stable noble gas after helium. Now Na plus, that is Na atomic number 11, after loss of 1 electron it become 2,8. Magnesium 12, after loss of 2 electron it become 2,8. Potassium 19, after loss of 1 electron it become 2,8,8. Calcium 20, after loss of 2 electron it become 2,8,8. Fluorine atomic number 9, it gain 1 electron and attain octate, that is stable electronic configuration. Please take the screenshot of this screen. Now in this screen we are going to see that why elements are reactive. Now elements are reactive other than noble gases because in periodic table all the elements want to attain the electronic configuration of nearest noble gas. Either helium, in case of helium they are completing duplet, and in case of other noble gases they are completing octate. So now to gain stability, to attain the electronic configuration of nearest noble gas, element either lose electron or gain electron, even or share electron. In case of metal have 1, 2, 3 electron in outermost shell, so it is easy to lose electron and attain the electronic configuration of nearest noble gas. If sodium lose 1 electron, it complete octate. If magnesium lose 2 electron, it attain the electronic configuration of nearest noble gas. That is what noble gas? That is neon. So if we can compare between sodium and magnesium also, sodium is more reactive than magnesium because sodium attained electronic configuration after loss of 1 electron, while magnesium attained electronic configuration of nearest noble gas after loss of 2 electron, and they are next to each other. Then we can compare. Similarly, fluorine and oxygen can be compared. They are next to each other. Now, fluorine and oxygen, they are non-metal and they are going to gain electron. Fluorine will gain 1 electron and attain the electronic configuration of nearest noble gas. Oxygen also accept 2 electron and attain the electronic configuration of nearest noble gas. So if we are comparing between these two, fluorine and oxygen, fluorine is more reactive than oxygen because fluorine take 1 electron to complete its octate and oxygen required 2 electron to complete their octate. We are comparing only in that case if they are neighbor. Now if we are talking about alkali metals, first group elements, reactivity increases down the group due to increase in size. Now if we are comparing between lithium and sodium, sodium is bigger than lithium and removal of electron from sodium is easier as compared to lithium. In case of sodium, the electron is in third shell, we are going to remove that electron, and lithium we are going to remove the electron from second shell. So removal of electron from third shell will be easy as compared to the electron from second shell. Why we are comparing between these two? Because they belong to the same group and they are next to each other. In case of alkaline earth metal, what is that? Same thing will be followed. Reactivity increases down the group due to increase in size. Take the screenshot and make the notes.